And finally, we've arrived at our last entity to store, which is hashtags or tags. And we saved this one for last because, as I mentioned in the intro video, it's the hardest, I guess. Well, it doesn't have to be, but there's a couple different solutions we could go about, and I wanted to have a discussion about which is best, if there is one answer. So let's step through 3 potential structures that we could use. And remember, the way that this works is that one photo can have 10, 20, 50 hashtags. I do think there is a limit on Instagram. I mean, you can keep adding them as many as you want, but only 30, I believe, actually will show up. Or it's not that they won't show up, but it's that when you search for a hashtag, your photo will only show up if you use less than 30. Anyways, we're getting off track here. But the idea is you can add hashtags to a photo, but then you can also, go click on a hashtag and see all the associated photos with it. So here's one way we could structure it, which might seem maybe the least obvious to you, which would be to do it like this, where we actually just have our photos table, but we add a column called tags, and it's a string, just a varchar that just has our tags, and we could separate them by the hash sign, the octothorpe, or by spaces or dashes or something, but we're just storing them together. And this could work, and places do use this. I've seen it suggested, at least. I haven't seen it in practice, but you can imagine how it would work. To add a new tag into something, you'd basically just take all the other tags and then concatenate in at the end a new tag, or at the beginning. And then you could have an order to, figure out which ones were posted first, I guess, based off of that order that they're in. And it's pretty simple. If you wanted to find all photos that are tagged with cute, you just basically have to use like, where tags like cute. But then, as you can see down here, there are a couple problems. Let's start with an advantage, which is that it's very easy to implement. You don't need any other tables, but there are a couple disadvantages. One is that there's a limit to how many tags you can have in there, which is the length of, whatever the column is. If a varchar, whatever the maximum length is, you can only put so many in there. The other problem, or another problem actually, is that you can't store additional information like, if we wanted to store the first time a hashtag was used. If I wanted to be able to see the first person to use the hashtag, whatever, cat or something, I'm not storing the time that something was tagged because, on Instagram, you can add hashtags after the fact. I'm sure they're storing that when they're tagged so that they can track trends as hashtags come and go. So it doesn't allow us to store additional information like that. And then the other thing that's kind of important is that you have to be careful when you're searching for stuff. So if I was trying to find the hashtag food, and I wanted to see nice food, beautiful food, so the hashtag is just food, well, it will return this, which has sad food, if I'm just doing like food. So I'd have to be careful, and I need to add spaces maybe to make it easier to separate things out. Basically, you just have to be careful. There's ways around it. We've seen them before, how you use search with like. But the point is, this is an easy solution, but it's not going to be the best, and it's not the best for us right now. So another solution is to use 2 tables. So we have our photos as our photos table currently is now, but then we have a tags table where we have our tag name, in this case cute, and then a corresponding photo ID. So, if this photo with ID of 1 is tagged cute, we put it there. And then a photo with ID 3, which is the selfie here, is also tagged cute. And then photo ID 2 is tagged with microwave, and 3 with ego, 3 with smile, 2 with gross. So as you can see, we can have a single photo with multiple tags, like here, where we have this selfie. ID 3 is tagged with smile, ego, and cute. And we can also have tags that are applied to multiple photos, like cute. It's applied to the first photo and the third photo. So this works. There's unlimited number of tags. That's an advantage. We don't have to worry about how many can fit into the string. But a disadvantage is that, for one thing, we are storing, these tag names over and over and over, and these are strings, and that it's maybe not ideal to store all these different strings and have duplicated data. But it's not a big deal. The duplication isn't the problem. Really what it comes down to is that this is actually slower than the previous solution when it comes to things like inserting or updating or deleting. But then another problem is that it's actually slower than the previous solution. So in just a moment, I can show you a comparison that I didn't do, but there's a great article that I found where somebody does a speed test between these, the three solutions, to figure out when they perform best. So this is not one we're going to use either, but solution 3 is, which maybe you got, it involves 3 tables. So we have our photos table, unchanged. We have a different tags table. So this tags table is just a tag name and an ID. And then we have a middle table, a join table called photo tags or tag photos or taggings or something, whatever you want to call it, which is an instance of a hashtag being applied to a photo. And all that it is a photo ID and a tag ID. And that's it. So in this case, photo ID 1 is my cat is being tagged with cute. And then the same photo, my cat is being tagged with pets. And then we have, we can keep going. My meal is being tagged with microwave. And my meal is being tagged with gross, and so on. So we have these, 2 columns, and that's pretty much it. The advantage, again, just like the previous one, there's an unlimited number of tags, and we can also add additional information. So if I wanted to, when a tag is created the first time over here, I could store the first time it was created. And then over here, every time it's subsequently used, I could store, the time it was used or something. And so I'm sure there's some interesting data you could garner from that, or the location of where in the world it was used or something like that. The time of the day, I don't know, day of the week, whatever. And we also have less duplication of the tags over here. But then there are a couple problems, and they really come down to just more work. So when we're inserting something, if it's the first time a hashtag's been used and it's not in the database yet, we have to create it, and then we have to associate it with a photo using photo tags. And the same thing when we're updating. We have to... What? She just vomited. Anyway. And then we also have to worry about orphans. We should always all be worried about orphans, but in particular when we're talking about these tables, when we're deleting something, right? If we delete a tag for some reason, which Instagram does, if there's a problem, if something is being misused or somehow being, controversial, they can be removed. And so then we just have to make sure when we're removing it from here, we also need to remove it from all associated photo tags. So it can be a bit more complicated. But basically it comes down to the cost of having this nicer structure is that it's just a little more work. And just as an end note here, I did mention earlier that there is this great article online, this guy who does speed tests of different ways of doing tagging. And it's written up. I'll include the link along with this video if you want to read it. I'll just spend 10 seconds talking about it. But basically, he does some tests here to show that depending on, one, the size of your data set, this example with a smaller data set, the second and third approaches I showed you with multiple tables are actually faster. But then as we get a larger data set with thousands of tags, it actually changes. So it's just interesting to note that and to read. But also it talks about how much time it takes to insert compared across the 3 different versions. And it's just an interesting article. But if you actually look at his conclusion section, which is probably what most of you care about, where is that? Is that he actually thinks that it would be best to have, if you're working on a huge app, to have 2 versions. The first version I showed you and the third version I showed you. And basically they are perform best in different situations. And this is getting into the woods a little bit, but basically the version that we're going to go with, the third one with 3 different tables, is faster if you're working with common tags, things that are used often. But if you're searching or you're trying to do joins with like rare is the wrong word, but uncommon tags that just aren't used very often, then it's actually slower, and it would be faster to do the first version I showed you where you store them as text. So this guy is suggesting to use a combination of the 2, which we're not going to get into, but it's just interesting to note that there isn't one best way, and that it really comes down to your needs, what your app needs, the product needs dictate. And in all likelihood, as an app like Instagram grows, or especially when it started out to where it is now, its schema, its database has undergone multiple big overhauls and changes. Probably not just the schema itself, but the database, whether it's going from something like MySQL to another type database, or a bigger change going from a relational database like MySQL to a non-relational database. So it's really hard to say what's best. But it's interesting to take a look at somebody who's actually crunched the numbers, and even after doing that, can't necessarily give a definitive answer, because the answer is it depends.